Hello everyone, welcome back to my channel. This is the ninth video in this series. Topic is clustering. Introduction to the K-mean clustering algorithm. There are many different clustering methods including hierarchical clustering, network clustering and bridge clusterings. Here we shall focus on the K-mean clustering algorithm. And this is the step of algorithm. Ask the user how many clusters K the dataset should partitions into. Randomly assigns K records to the initial cluster center locations, and third step is for each records find the nearest cluster center. Thus, in a sense, each cluster center owns a subset of the records, thereby representing a partition of the dataset. And fifth step, we repeat step 3, 5 until convergence of termination and demonstrate applications of K-mean. इसके application से clustering using Python. We apply the K-mean clustering algorithm to the wine training and the white wine test datasets we will discuss in previous videos. These datasets are adapted from the wine quality datasets and UC13. The data consists of chemical and quality characteristics of a collections or particles white wines. The predictors are alcohol and sugar. The target variables is quality of measure of how good the wine is according to a professional tester. एंड प्रोफेशनल टेस्टर के बाद हम डिसाइड कर पाएंगे कि वाइन की क्वालिटी क्या है उस लो है हाई है when constructing cluster it is important to not include the target variables as an input to the clustering algorithm. It is also important to standardize or normalize all the predictors so that the greater variability of one predictor does not dominate. The cluster construction process, the K-mean algorithm requires the analysis to specify the desired. For simplicity, we specify k equals to 2 clusters. And this is basically tables main variable values by cluster for the white wine training data set. K-mean clustering algorithm to the predictor variables alcohol and sugar Python are used. In this table, we will discuss so the means variables value for each predictors for the two resulting clusters. Cluster 1 contains 712 wines and a mean sugar contains 0.96 standards. Cluster 1 value for the standardized normal sugar Z value is 0.96. Cluster 1 means alcohol content however lies 0.76 standard deviations below the mean. Alcohol level for all wines on the other hand. Cluster 2 contains 1097 wines with lower mean sugar content than cluster 1. So we may identify cluster 1 as containing sweet wines, high in sugar but low in alcohol, and while cluster 2 contains dry wines low in sugars but packaging a higher alcohol punch. Perhaps the most important cluster validation method is to obtain cluster that makes sense to a subject matter expert. During fermentation, yeast transforms sugar into ethanol alcohol, so it is a surprise that our clustering algorithm has uncovered these two natural clusters of white wines, sweet wines, and dry wines. The dry wines have on the whole evidently undergone longer fermentation than the sweet wines. Thank you.